Let's say you want to fine-tune a massive 7 billion parameter AI model the traditional way. Well, that means you have to update all 7 billion of its weights plus all the optimizer memory that comes with them. It's a huge barrier to entry. We're talking about a total memory cost of over 100 gigabytes just to train the thing. That is absolutely not going to fit on any GPU you might personally own.
But here's the crazy paradox. How in the world are people fine-tuning these exact same massive models on a single consumer graphics card and doing it in just a matter of hours? I mean, it sounds totally impossible, right? Especially when you contrast those massive data center supercomputer requirements with the reality of doing it right on a personal GPU. Well, the answer to this whole puzzle is a really cleverly designed technique called LoRA.
To understand why LoRA is such a game changer, in this explainer, we have to look at the old method. The danger of traditional full fine-tuning is pretty severe because it touches every single part of the model. You run into this huge risk of something called catastrophic forgetting. That basically means the model can actually forget its old abilities while it's trying to learn your new task. Think of it kind of like renovating a house by, completely demolishing it all the way down to the foundation and rebuilding literally everything. The walls, the plumbing, the wiring, the whole shebang, just to update one single kitchen. It's just an incredibly destructive and expensive way to make a change.
So that's where LoRA steps in. LoRA, which stands for low-rank adaptation, takes a much smarter renovation approach. Instead of tearing everything down, it keeps that solid foundation exactly as it is. It leaves it completely untouched and essentially just adds a small, brand new kitchen right alongside it. You completely avoid messing with the entire pre-trained model. Concretely, LoRA operates in 3 distinct, really elegant steps. Step 1, it just freezes the entire pre-trained model so it remains completely untouched. Step 2, it adds these really small trainable adapter matrices right next to the existing weights. And then step 3, during use, the input flows through both paths at the exact same time and their outputs combine. So the frozen model is still doing all the heavy lifting, while that tiny little adapter simply nudges the output toward your specific task.
The math making this all possible is just incredible. To put it into perspective, a typical weight matrix in a large language model has over 16 million parameters. Full fine-tuning wants to update all of them, but LoRA instead uses 2 much smaller matrices whose product basically approximates the needed change. Together, they total only about 130,000 parameters. That is less than 1% of the original. And actually, that narrow bottleneck forces the adapter to capture only what truly matters, which beautifully prevents the model from overfitting on smaller datasets.
But wait, it gets better. You can take this incredible efficiency even further when you pair LoRA with something called QLoRA. QLoRA is this brilliant optimization that essentially forces that massive, frozen base model into a highly compressed 4-bit precision state the moment you load it.
So what does this actually mean for you and your hardware? Well, here's the final math. A model that originally needed a whopping 14 gigabytes of memory now drops down to needing about 3.5 gigabytes. 3.5! Suddenly, a massive 7 billion parameter model fine-tunes comfortably on a single consumer GPU instead of requiring an entire data center.
It really all comes back to our renovation analogy. You're not rebuilding the house, you're leaving the foundation alone and renovating just the kitchen, and that is absolutely enough to make it truly yours. So what kind of kitchen will you build now that the tools fit right on your desk?